Hi everybody, let's continue our discussion of profit and move on to profit maximization. We spent some time in class today discussing what profit is, and now we're going to talk about the quantity of output that will maximize a producer's profit. We're going to discuss 5 different ideas. We're going to talk about the principle of marginal analysis. We're going to talk about marginal revenue and what that is. We'll talk about the optimal output rule, marginal cost curves, and the marginal revenue curve. Now, in class today I mentioned that there was what I think is an interesting Milton Friedman video out there, and I've given you the link here. If you have 5 minutes to watch that, we may watch it in class tomorrow as well. Okay, let's start our discussion of profit maximization with an example that is a pretty straightforward way, I think, of helping us decide, looking at the data that will help us decide where to maximize profit. So what do we have in this chart? We have quantity of tomatoes that are being produced or grown. We have total revenue, which you will remember is price times quantity. And here we know that the price is $18 a bushel. So we have number of bushels times the price gives us these numbers. Total cost we have given, and you'll recognize that if this is the total, then there must be something in between, which is additional cost or marginal cost. And we'll get into defining that further in just a minute. We then have a column of profit, which is nothing more than total revenue minus total cost, similar to the sandbag example today where total revenue was $2,500 and total cost, when we were talking about explicit cost, was $2,250. You'll remember that when we got to implicit costs plus explicit costs or opportunity costs, we actually were in a negative profit situation. But here, total revenue minus total cost is given in each of these numbers. Now, you'll notice that what is the profit maximizing production quantity? Well, it's simply the quantity where we get the most profit. It turns out here that the profit maximizing quantity is 5 bushels. Let's get a little more in depth and talk more about this idea of marginal cost. We're also going to talk about marginal revenue, additional revenue generated by production of an additional unit. Let's move on and better understand this idea of using marginal analysis to determine the profit maximizing output. Well, first of all, what's the principle of marginal analysis? The principle of marginal analysis says to do what you're doing until marginal benefit equals marginal cost. Well, what is marginal benefit? Marginal benefit of an additional unit is the additional revenue generated by selling it. That's also known as the marginal revenue. So you remember from this case, we had revenue and we had additional revenue generated each time. Well, in this case, the marginal revenue happens to be the same in every single additional unit, and it's $18. So we know what marginal revenue is. We know what marginal benefit is. Let's start quantifying this and putting it into an equation that we can use in calculating marginal revenue. Well, marginal revenue equals the change in total revenue, so additional revenue, over the change in quantity. So MR, marginal revenue, equals delta TR, so I think you'll recognize this as change in total revenue over change in quantity. Now, the optimal output rule that says produce until marginal revenue equals marginal cost is very, very similar to profit maximization. Profit maximization in this particular example showed us that there was a quantity that maximized our profit being defined as total revenue minus total cost. To dig deeper into this, the optimal output rule tells us to produce until marginal revenue equals marginal cost. Okay, so what does marginal revenue equals marginal cost mean for the farm that's producing tomatoes? Well, similar graph here with a couple of columns added. We have total cost, we have marginal cost of each bushel, again marginal cost equaling change in total cost over change in quantity. So here we have total cost going from 14 to 30, which is $16, and we have 1. So that is a change of 1 unit. Here we have 30 to 36, 6, change in total cost over quantity of 1, and so on and so on. Here we have marginal revenue of bushel, and in this case we know because it was a static $18 per bushel. That's the same for every single unit of output produced. We have one here called net gain of bushel. So marginal revenue minus marginal cost given in each of these numbers, and you can see It's simply this number minus this number. Now, when we're talking about this optimal output rule and producing where marginal revenue equals marginal cost, what do? We start looking down the marginal cost and we start looking down marginal revenue. What you'll notice here in this case, we have 18 for everyone, so you know that you're automatically looking for 18 over here. Well, the problem is we can't find it. In the case where there's no discrete amount, where the marginal revenue equals the marginal cost, what we do is produce at the amount just before we get to the marginal revenue amount. So you'd produce here at the amount that generates $16 of marginal cost, rather than going to 20, because at 20 you're losing money. You see here the net gain of the bushel is -2. So let's talk about how we get this on a graph, of course, because we like to graph everything. Marginal cost is shown here. This curve is nothing more than the marginal cost curve, or rather the collection of marginal cost measures from this chart. Here it is graphed, and you should get used to this sort of Nike swoosh looking marginal cost curve. Very, very typical for a marginal cost curve. You'll see it very high, you'll see it decrease, and then increase as your quantity of tomatoes, or rather quantity of whatever product increases. Also keep in mind here that in this case, marginal revenue equals price, and the marginal revenue is constant, unchanged, simply because that was how the question was stated. We will face cases where the marginal revenue is not constant like that, but for this case, it just makes it easier to understand it. What does this mean? Well, if the law of the optimal output rule says that we should produce where marginal revenue equals marginal cost, that means that we produce at the profit maximizing quantity of E. So the quantity is 5, and again, the marginal revenue is $18. That's it for tonight. That is pretty straightforward, I think, pretty basic starting understanding of profit maximization. So we had the principle of marginal analysis, analyzing each marginal unit. We had marginal revenue, revenue generated by an additional unit of production. We had the optimal output rule that said produce where marginal revenue equals marginal cost. We had the marginal cost curve, and we had, that's marginal cost curve, and marginal revenue cost, and the marginal revenue curve. Have a great evening, and I will see you tomorrow.